At WindBorne Systems, we improve forecasts with smart weather balloons. Millions of people and billions of dollars rely on accurate hurricane forecasts. Hurricane Ian cost $63 billion in insured losses alone and took more than 100 lives. Meanwhile, military success has hinged on weather from D-Day to Ukraine. The SEAL team sent to kill bin Laden had to reschedule their strike for another day because the wind was too fast to land. And these are just two examples. Driven by climate change, billion-dollar weather events are growing at a staggering rate, costing hundreds of billions per year. But even the best weather models differ. This was the outlook for Hurricane Ian. An error of 100 miles is the difference between staying put and evacuating. When weather is so important, how is it that we can still get it so wrong? Why do we still not trust the weatherman? The problem is the massive data gap. Only about 15% of the Earth's surface has regular in-atmosphere observations, but weather is a global system. Right here in California, practically all of our weather blows in from the Pacific Ocean, one of the world's biggest data deserts. To better predict the weather, you need better weather data. And existing technologies can't plug this gap. The laws of physics prevent satellites from collecting the most critical weather observations. To solve this problem, we invented a new kind of smart weather balloon that we developed while we were students at Stanford. We took innovations in consumer electronics, 3D printing, machine learning, and satellite communications, and applied them to weather balloons to create a new altitude control technology and the most sophisticated weather balloon on the planet. Our balloon is the best weather observation tool ever built. Where a normal balloon flies for only 2 hours, ours can fly for more than 400. We can reach the data no one else can. Because each balloon flies for so long, we can collect data in an entire hemisphere from just a handful of launch sites. And the balloon's low cost means we can collect data at unprecedented densities. Since this project started at Stanford, our capabilities have been improving exponentially. We're on track to be able to collect 10,000 times more data per dollar than alternatives. And our capabilities meaningfully improve weather forecasts. Our balloon data already improves America's best weather model by more than satellite GPSRO did when it was first introduced, and it's only getting better over time. We start by selling data in the public sector. We're already working with 7 organizations. They're in conversation with 7 more. Selling data is the first piece of how we scale. We have contracts for $2.1 million on top of $3.6 million in grants. If we convert the customers in our pipeline, we'll have $30 million in ARR and are aiming for $100 million in data sales in the next few years. And our gross margins are over 50% and getting better. We've already been paid to collect 47,000 hours of data for the Air Force, Navy, and NOAA. For NOAA, we even flew a balloon into Hurricane Ian. And our customers love us. Here's an unsolicited email we got from an Air Force major asking about our timeline for mass orders. We have more requests for demos than we have the bandwidth to execute. Our traction selling data matters because it pays us to collect an unrivaled data set. From there, data network effects enable creating industry-leading forecasts. That's our path to access the $63 billion market for weather intelligence. We sell both data and the forecasts that data enables. We've been addicted to this since we were freshmen at Stanford and have now brought on world-class meteorology talent. Todd spent 25 years developing weather models, including leading the team behind IBM's proprietary weather model, the largest weather model operated by a private company. Our mission is to cover the world in sensors to improve forecasts and mitigate the climate crisis. If you want to join us, we're raising our Series A in Q1 of 2023.